Okay, so today we continue our conversation about human populations, and we're going to start to talk about this concept of the demographic transition. So let's jump right in. And before we can talk about the demographic transition, we want to make sure that we can talk about how human population changes. And because the demographic transition is all about those changes. So, first, before we can talk about how they change, we have to talk about how we measure them. So, we have a few different ways that we talk about this. The first thing that we'll talk about when we're measuring human populations is what we call the crude birth rate. And the crude birth rate is the number of births per thousand people. So, notice that this is per thousand, not per hundred. So, when we talk about birth rate, we're not talking about a percentage, we're talking about a number per thousand. And we also calculate the crude death rate in the same way. It is the number of deaths per thousand individuals in the population. So those two numbers together, crude birth rate and crude death rate, will allow us to calculate a change in the population. And if we subtract death rate from birth rate, we will get the change in population per thousand people. Unfortunately, we usually calculate change in population as a percentage. And so, in order to get to that change in population as a percentage, we'll need to take crude birth rate, subtract crude death rate, because that's the number of new people added per thousand people, and divide it by 10 to get that number per 100 people, which would then give us a percent. So, again, crude birth rate and crude death rate are both measured per thousand people. But when we talk about growth rate, we want to measure it as a percentage. So we'll have births minus deaths times divided by 10. Okay, so the other important number that we'll talk about when we're measuring human populations is population density, and that is the number of people per unit area. Okay, so what can we do with this information? We can start to calculate how populations are going to grow. So if we know the growth rate, that percentage, we can take the initial population, we can multiply it by the growth rate expressed as the growth rate as a decimal plus one raised to the number of years. And that's going to give us the final population. So, for example, if we have a city or an area with 468,843 people, and it's growing at 3% per year, we're going to express that as 1.03, and we're going to raise it to the power of 10 for those 10 years. That means after 10 years, our 468,843 people are now going to be 630,085 people. So that is a calculation that you may be asked to do in class. It is not a calculation that you'll be asked to do in this particular form on the exam because we don't have calculators. So, however, there is a short and easy way to figure out how long it will take a population to double. And that is that because it's an exponential relationship, if we divide the number 70 by the growth rate expressed as a percentage, that will tell us how long it will take a population to double. So if, for example, we have a growth rate of 3.5%, we divide 70 by 3.5 and we get 20. So that population will take 20 years to double. Okay, let's talk about the demographic transition. So this is a combination of economics and human population dynamics. So when we talk about the demographic transition, we talk about four stages. The first stage is the one that we call pre-modern. The second stage we call urbanizing or industrializing. You will frequently hear this called the transitional stage. Stage 3 is the industrial stage or the mature industrial stage. And stage 4 is post-industrial. So in stage 1, which is here on the graph, we can see, so our red line is our crude death rate, our blue line is our crude birth rate. So we can see here in this early stage, this pre-modern stage, that crude birth rate and crude death rate are almost the same, which means that this is a fairly steady population size. Countries in this stage are generally not industrialized yet and may even still be hunter-gatherers. There are pretty much no countries that are considered to be in stage one now. There are areas, most of these are areas that contain indigenous groups in remote areas. So some of the tribes in the Amazon rainforest, the occasional Polynesian island are considered to be in this stage. In this stage, we have a very short life expectancy because food resources are scarce. We have high infant mortality, again, because of poor food access, frequently poor water access, and certainly very little medical access. There's a lot of disease and poor sanitation in this stage. So, stage two, now we start to see rapid growth of the human population because death rates are declining. This is the stage where food resources become much more consistent. We also start to improve access to healthcare, clean water, vaccinations. But culture changes slowly. People are moving to cities for jobs, but they still retain the habits of having lived in a non industrialized time or place. And so birth rates tend to stay high. So, with that better access to food and water and healthcare, death rates decline, but birth rates are high. This means that population begins to explode. In addition, for sometimes cultural reasons, very often for financial reasons, logistical reasons, many women are not educated in this stage. And so that also contributes to birth rates staying high. So there's an imbalance between birth rate and death rate. Once we reach this mature industrial stage, as family income increases, birth rates decline. Women have better access to education, better access to birth control, more information about the whole process of birth and pregnancy. The need for multiple children is declining, so societal pressure to have multiple children starts to decline, and birth rates start to go down. Death rate is still continuing to decline. And so towards the end of stage three, crude birth rate is reaching the same as crude death rate. And so this population is still growing, but it's growing much more slowly. And stage four is what we consider the post-industrial stage. In this stage, generally speaking, crude birth rate starts to fall below crude death rate. It tends to be highly affluent countries that are in stage four, and they have high levels of economic development. They have large populations of elderly people, and so their countries start to shrink. Their populations start to shrink. So in a lot of cases, immigration or the influx of new people into the country starts to become the solution because in order to support that elderly population, you need younger people to take the jobs and to continue to pay into the system. So, four stages of demographic transition: pre modern, transitional, industrial, and post industrial. All right, let's look at populations around the world. So we have this quick little graph. You can see that the US is definitely one of the larger populations, as is Russia and Brazil. However, the largest countries are China and India. So you definitely should be able to identify areas with heavy populations. Okay, population density. Now we're into that idea of how many people per unit area. And you'll notice that although the US has lots of people, they tend to be pretty spread out. Canada tends to be even more spread out, as does Russia. But again, China and India have very high population densities. Most of Western Europe has very high population densities. So, also an important factor to know. And then let's talk about growth rate. So, growth rate is, again, that percentage change. So you can see that most of Eastern Europe and Russia is very low. Most of the US, Western Europe, and China also have low population growth rates. Africa tends to have very high growth rates. South America and the rest of Asia tend to have medium growth rates. Again, it's important that you are able to identify the areas with fastest rates of change and lowest rates of change. Okay, so one more thing to talk about as far as financial impact. Um, This IPAT equation is a huge oversimplification of the factors that cause environmental degradation. But the simple equation is that impact is equal to population times consumption per person times the impact per unit of consumption. That would be population times affluence times technology. Okay, as we have more technology, each individual unit of technology tends to have a larger impact on the environment. The more affluent a country is, the more consumption there is. So this is a vast oversimplification, but it does give us some idea of the impact of a population on the environment. However, when we talk about affluence, it is important to recognize that when we have very affluent countries, that they do tend to spend more money and energy on environmental improvements. So that can mitigate this piece a little bit. And when it comes to technology, it can be destructive. Creating batteries, it releases a lot of toxic chemicals. There's more resource extraction. So it can have a negative impact, but technology can also have a very positive impact in terms of coming up with green solutions that increase efficiency and lower the impact of each of those individual technology pieces. Okay, so that's it for our 4 stages of the demographic transition for calculations on how populations change and just a few important things to know about populations around the world. As always, if you have questions, please let me know.